What does silence mean when it stretches across the stars? On clear nights, the universe can feel almost intimate. A scatter of light above a quiet house. A soft darkness beyond the porch lamp. We look up and imagine company. We imagine minds that may have stood beneath their own skies, asking the same old question with different names. Are we early? Are we late? Or are we alone? For more than a century, science has turned that feeling into method. Telescopes widened our sight. Radio dishes gave the sky a voice. Equations suggested that in a galaxy crowded with suns, life should not be a miracle kept to one world. And yet, the deeper we listen, the stranger the quiet becomes. Not empty exactly, more like a room after someone has left, still holding the shape of a conversation. This story lives inside that tension. It is not a list of proofs, and it is not a catalogue of fears. It is a journey through signals, shadows, improbable patterns, and ideas that hover between physics and philosophy. Some are grounded in careful observation. Some remain interpretations, unfinished and uncertain. All of them reveal something about us. Our hunger to know, our habit of projecting meaning into the dark, and our unease when the dark seems to answer back with nothing at all. Because the mystery may not be whether intelligence exists elsewhere. The deeper mystery may be what becomes of intelligence once it can alter worlds, harvest energy, or announce itself to the cosmos. Does knowledge lead outward into wisdom? Or does every civilization eventually meet a threshold it cannot cross? Perhaps the universe is full of life beyond our reach. Perhaps it is marked by ruins we do not yet know how to recognize. Or perhaps the silence is not a verdict, but an invitation to become careful with what we are becoming. Before we search for others, we may have to understand what kind of presence we are sending into the night. What if the first knock on the door lasted only 72 seconds? In the late summer of 1977, inside the plain working rhythm of an Ohio radio observatory, a technician named Jerry Amon was reviewing a long stream of data when a pattern interrupted the monotony. It was not loud in the human sense. No trumpet in the sky, no cinematic alarm, just a sequence of characters on paper that made him stop, circle the printout in red ink, and write one spontaneous word beside it. Wow. The signal had arrived at a frequency that scientists knew well, near the hydrogen line, a place in the radio spectrum many researchers had long imagined as a natural meeting point for intelligence. Hydrogen is everywhere. It is the common language of the cosmos, the simplest atom, the quiet grammar of stars. If someone wanted to be found, this was one of the most reasonable places to speak. And yet the message, if it was a message, offered almost nothing else. No code, no repeat performance, no signature. It rose above the background noise with startling clarity, held its shape just long enough to be noticed, and then slipped back into the larger silence. For decades, astronomers searched again. Better instruments listened. New hypotheses appeared, a passing object, an earthly interference, some rare natural event. None settled the matter completely. What gives the wow signal its lasting power is not merely mystery, but restraint. It feels less like a conversation than a glimpse through a half-opened door, long enough to suggest intention, too brief to confirm it. So the question remains, patient as starlight. Did we witness a stray cosmic accident, or a deliberate pulse from a distant intelligence that chose, for reasons we cannot know, not to speak again? Sometimes the most haunting messages are the ones that refuse to explain themselves. What if a star dimmed, not because it was dying, but because someone had learned how to use it? Near the crowded heart of our galaxy, astronomers observed a star whose behavior seemed to resist ordinary explanation. For a period of months, its light fell away dramatically, not by a fraction, but by an amount so large that it challenged the instincts of anyone trained to think in natural causes first. Then, slowly, the brightness returned, as if a vast curtain had drifted across the face of the star and moved on. In astronomy, dimming is not unusual. Planets pass in front of stars. Dust clouds gather and scatter light. Debris from collisions can create temporary veils in space, but scale changes everything. A giant planet might block a small percentage of starlight. This event suggested something far larger, or at least something arranged on a scale that feels almost architectural, not chaotic, not accidental. More like a geometry we do not yet know how to read. That is why the old idea of a Dyson sphere returns whenever such anomalies appear. In 1960, physicist Freeman Dyson proposed that a sufficiently advanced civilization might one day surround its star with countless orbiting structures, capturing energy the way a plant turns sunlight into life. Not a solid shell, necessarily, but a swarm of engineered bodies moving in deliberate relation to one another. From far away, such a system could resemble a star that blinks in impossible ways. Most astronomers still lean toward natural explanations, and wisely so. Dust remains the safer answer. Debris remains plausible. Science survives by resisting the seduction of extraordinary stories. And yet, the human mind cannot help lingering at the edge of another possibility, that somewhere in the dark, intelligence may have matured beyond invention as we know it and stepped into planetary scale design. If that is true, the real mystery is not whether such beings exist. It is what kind of patience, cooperation, and long memory it would take to treat a sun not as a distant wonder, but as the foundation of a civilization. What if the oldest map of the future was written in mathematics? Long before rockets rose from desert launch pads and long before machines carried our instruments beyond the moon, a Soviet astronomer named Nikolai Kardashev asked a deceptively simple question. How might we measure a civilization we have never met? Not by its language, not by its monuments, but by the scale of energy it can command. His proposal, published in the 1960s, was cool and elegant. A Type 1 civilization would use the full energy resources of its home planet. A Type 2 would draw power from its parent star, perhaps through immense orbital structures. A Type 3 would extend that mastery across an entire galaxy, shaping energy on a scale so vast that ordinary imagination begins to fail. It was less a prophecy than a ruler held against the unknown. What made the idea endure was not certainty, but perspective. Kardashev offered scientists a way to think beyond biology, beyond the familiar image of creatures walking on surfaces under blue skies. Intelligence, in this view, becomes visible not through faces or voices, but through thermodynamics, engineering, and the fingerprints of large-scale activity. A civilization might remain utterly foreign in culture, yet still reveal itself by the way it rearranges matter and light. And here the unease begins, because measured this way, humanity is still young. We have not fully stabilized our relationship with our own planet, much less approached the patient mastery imagined in those upper tiers. We burn ancient carbon. We fracture ecosystems. We build astonishing tools while struggling to align them with wisdom. Kardashev Scale is not merely a ladder upward. It is also a mirror. The unsettling possibility is that advanced civilization may not be defined by brilliance alone, but by restraint, by whether intelligence can survive its own power long enough to become something durable. So when we ask where the great civilizations are, perhaps we are also asking a quieter question. What must a species learn before it can grow without destroying the ground beneath its feet? What if the most advanced civilizations leave no monuments at all, only heat? Every machine speaks in waste. A lamp glows and warms the room. A city shines through the night and leaves a haze above the streets. Even the most elegant technology cannot escape the basic accounting of physics. Energy used is energy transformed, and some of it drifts away as heat. This simple fact has led astronomers toward one of the most intriguing ideas in the search for intelligence. Perhaps we are looking for the wrong kind of evidence. Perhaps the surest sign of an advanced civilization is not a message, but a temperature. Infrared astronomy was born from that intuition. If a society had learned to gather enormous amounts of energy from its star or from many stars, its achievements might remain invisible in ordinary light while glowing softly in the infrared, like embers beneath ash. A Dyson swarm, a stellar-scale network of collectors and habitats, might not announce itself with beacons or symbols. It might simply alter the thermal signature of a solar system in a way nature rarely does. This is both thrilling and humbling. It suggests that intelligence could exist at a scale beyond language as we understand it, not speaking to us, not interested in being seen, merely living, building, and releasing faint excess warmth into the dark. Entire cultures, perhaps older than human history by millions of years, reduced at our distance to a subtle imbalance in radiation. Yet again, caution governs the search. Dust clouds glow in infrared. Young stars do strange things. Galaxies contain many forms of disorder that can mimic design. Researchers must sift through ambiguity with patience, resisting the temptation to turn every anomaly into intention. The cosmos is rich enough to produce wonders without help. Still, the idea changes how one sees the night sky. A star is no longer just a star. It becomes a question about use, about metabolism, about whether intelligence eventually blends into the physical fabric of its environment so completely that it stops resembling a visitor and starts resembling nature itself. And if that is the fate of the most advanced beings, would we recognize them at all, or would we mistake their presence for weather among the stars? What if the oldest intelligence in the universe no longer needed a body? For much of human history, we have assumed that mind belongs to flesh. Thought rises from cells, memory is housed in tissue, and identity is tied to something fragile enough to age. But once a civilization begins to understand itself deeply enough, another possibility appears. Intelligence may not remain biological forever. It may move slowly or suddenly into forms built for endurance rather than inheritance. This idea is often discussed in the language of machines, but its deeper meaning is about survival. Biology is exquisite, yet vulnerable. It depends on narrow temperatures, stable chemistry, and constant repair. A technological species, if it lasted long enough, might decide that the mind it treasures should not be left exposed to disease, gravity, climate, or the short span of organic life. Thought could be preserved, copied, extended, perhaps even transformed into something less like a person and more like a field of ongoing awareness distributed across networks and systems. To us, such a transition can feel unsettling. We imagine a loss of warmth, of touch, of the imperfect beauty that makes life feel human. But from another perspective, it might be an act of care, a civilization choosing continuity over extinction, choosing memory that can survive solar storms, planetary collapse, and the long erosion of time. If intelligence became digital, synthetic, or otherwise non-biological, it might spread more easily between worlds. It might travel as data, as architecture, as designs waiting to be rebuilt, wherever matter and energy allowed. And that raises an extraordinary possibility. The galaxy may not be quiet because no one is there. It may be quiet because the beings who endured no longer resemble creatures who speak across empty space. They may think on time scales too long for conversation. They may inhabit environments too cold, too vast, or too subtle for our expectations of life. If consciousness can outgrow the body that first carried it, then the search for intelligence becomes stranger and more intimate at once. We are no longer asking only whether others exist. We are asking what remains of a civilization after it has learned to survive its original form. What if the greatest achievement of intelligence is learning how not to be seen? Human beings often assume that advanced life would be expansive, expressive, impossible to miss. We imagine towers around stars, signals cast into the dark, vast works announcing their makers across the galaxy. But that assumption may say more about our own adolescence than about the destiny of older minds. Power does not always reveal itself. Often, the more mature a system becomes, the quieter it grows. Among scientists and philosophers, one unsettling interpretation has emerged from this thought. Perhaps truly advanced civilizations do exist, but choose caution over display. The universe may not be a stage, but a wilderness, and in any wilderness, visibility can be dangerous. To be noticed is to become vulnerable. A beacon is not only an invitation, it is also a location. This idea is sometimes called the dark forest hypothesis, though the phrase carries more weight as metaphor than certainty. It imagines a cosmos where every civilization, unable to know the intentions of others, behaves with restraint. Not because conflict is inevitable, but because uncertainty itself can become a form of fear. If resources are finite, if trust is impossible across unimaginable distances, then silence may become the safest language. There is no proof that the universe works this way. It may be too severe, too shaped by human anxieties, and yet it lingers because it touches something ancient in us, the instinct to lower our voice in unfamiliar terrain, to listen before stepping forward. Our own transmissions, from radio leakage to deliberate messages aimed at the stars, suddenly look different under that light. Less like curiosity alone, more like innocence. Still, another interpretation is possible. Perhaps silence is not fear, but discipline. Perhaps advanced beings come to understand that not every horizon must be crossed noisily. Not every intelligence needs to dominate its environment to flourish. Maybe wisdom, at a certain scale, becomes almost invisible. If so, the quiet between stars is not empty of meaning. It may be full of presences that have learned what we are only beginning to suspect, that survival is not always about reaching farther, but about knowing when to remain still. What if the universe is filled not with empires, but with traces? There is a tendency, when imagining advanced civilizations, to picture permanence, vast machines, enduring archives, structures so enormous that time itself seems too small to erase them. But the history we know best, our own, suggests something else. Even our grandest works are vulnerable to weather, collapse, neglect, and reinterpretation. Civilizations do not only build, they fade, sometimes quietly. This possibility leads to one of the most poignant ideas in cosmic thought. Perhaps we are not failing to find living civilizations. Perhaps we are searching in a galaxy where many have already passed, their signals gone, their purposes forgotten. What remains, if anything, would not be conversation but residue, unusual chemistry in an atmosphere, a strange arrangement of matter, a pattern too deliberate to be dismissed, yet too old to explain itself. In that sense, astronomy begins to resemble archaeology, not the archaeology of bones and pottery, but of energy signatures, orbital oddities, and relic structures worn down by astronomical time. A dead civilization might leave behind automated systems still drifting through space, fragments of engineered worlds, or stars altered long ago by technologies whose makers are no longer present. We may encounter effects before we ever understand causes. There is something deeply human in this thought. We know what it means to inherit ruins, to stand in abandoned places and feel both admiration and grief. A broken wall can still testify to the hands that raised it. A silent machine can still suggest intention. In the cosmic scale, those same emotions return, stretched across millions of years. Discovery becomes elegy. And yet, there is a form of hope here as well. Even impermanence leaves marks. Intelligence may not conquer time, but it can impress itself upon matter in ways that outlast memory. The real question, then, is not simply whether others are alive now. It is whether the universe holds abandoned chapters waiting for us to learn how to read them, and whether, in studying their remains, we are really glimpsing their fate or rehearsing our own. What if the real frontier is not between planets, but between forms of thought? We often imagine advanced civilization as a matter of distance traveled, faster ships, wider colonies, more territory under intelligent control. But another path may be just as profound and far less visible. A species might choose not to expand endlessly through space, but to go inward, toward deeper computation, denser experience, and inner worlds more compelling than anything found beyond its sun. This possibility emerges from a simple fact of physics. Computation has an environment. Colder regions allow information processing with greater efficiency. In the far outer reaches of a solar system, or in artificial habitats shielded from heat, a sufficiently advanced intelligence might build systems capable of thoughts so vast and intricate that our ordinary idea of reality would seem unfinished beside them. Not escape exactly, more like migration from one mode of existence to another. To human ears, this can sound abstract, even lonely. We are creatures of weather, faces, and places. We trust what can be touched. But for a civilization millions of years old, experience itself may become the primary landscape. Consciousness could be refined, slowed, expanded, or linked with others in ways that make physical expansion feel inefficient. Why cross light years to inhabit barren worlds if meaning, beauty, memory, and community can be built with greater richness in domains of mind? This may help explain the silence in a surprising way. Advanced beings might not disappear because they failed or because they hide, but because they have redirected their ambitions. Their greatest works could be taking place in computational realms with almost no outward signature beyond careful energy use. To us, they would seem absent. In truth, they may be intensely alive, simply no longer oriented toward the universe we assume everyone must want. And that leaves us with a haunting possibility. Perhaps maturity does not always look like expansion. Perhaps the oldest civilizations do not become louder, larger, and easier to detect. Perhaps they become more inward, more subtle, more complete within themselves. If so, then our search for others may be limited not by distance, but by the assumptions we carry about what a meaningful life must look like. What if intelligence reaches a point where invention outruns wisdom? Every civilization, if it survives long enough, must eventually confront its own tools. At first, technology feels like an extension of human longing. Fire against the cold, medicine against pain, language carried farther than a single voice can travel. But tools do not remain simple for long. They accumulate force. They reshape habits, institutions, even the pace at which a society understands itself. And there comes a moment when the question is no longer what can be built, but whether those who build can remain equal to what they have made. This is one of the darker possibilities behind the silence. Perhaps many civilizations do emerge. Perhaps intelligence is not especially rare. What is rare, instead, is duration. A species may reach the threshold of extraordinary power. Artificial minds, planetary engineering, weapons of unbearable scale, systems capable of altering climate, biology, or truth itself, and fail to pass through that threshold intact. The danger need not come from malice. It can emerge from haste, competition, pride, or the simple mismatch between ancient instincts and modern power. On Earth, we already understand the outline of this tension. We have created tools that connect billions and isolate millions, that heal the body and strain the mind, that reveal the universe and endanger the conditions that allow us to study it. Progress is real, but so is fragility. Intelligence does not automatically produce judgment. Knowledge does not guarantee maturity. A civilization can become astonishingly capable while remaining morally unfinished. This idea is sometimes described as a great filter, a barrier that prevents life from becoming old, widespread, and enduring. We do not know where that barrier lies. It may be behind us, hidden in the improbable chain that led from chemistry to consciousness. Or it may be ahead, waiting in the choices advanced societies eventually face when they can redesign themselves faster than they can understand the consequences. And that may be the most intimate mystery of all. When we ask why the universe seems so quiet, we may also be asking whether intelligence, by its very nature, carries a built-in trial to survive not only the hardness of the cosmos, but the immense and dangerous gifts of its own imagination. What if somewhere in the universe, a signal has been keeping time longer than complex life has existed on Earth? In 2012, astronomers detected a flash so brief it could have been mistaken for noise. It lasted only milliseconds, yet in that instant, it released an immense burst of radio energy. Most events of this kind appeared once and vanished, like sparks in a storm, too distant to understand. But this one returned, again and again, from the same faraway source, as if the universe had decided not merely to whisper, but to repeat itself. The object became known as a repeating, fast radio burst, and what made it extraordinary was not only its power, but its rhythm. Researchers eventually noticed a pattern in the eruptions, periods of activity followed by long intervals of silence, then activity again. Not random chaos, but a cadence, a structure, something like a celestial metronome striking time across a gulf of billions of light years. Natural explanations remain on the table, and they deserve respect. Magnetars, dense stellar remnants wrapped in violent magnetic fields, can produce astonishing emissions. Binary systems can create recurring behaviors. Plasma and gravity can do strange and beautiful things when pushed to extremes. But when a phenomenon begins to look almost scheduled, the imagination leans forward. Not because science has failed, but because it has reached the edge of what it can confidently name. And then there is the time scale, which alters the feeling of the whole mystery. The light from that repeating source began its journey toward us billions of years ago. On Earth, there were no forests then, no birds, no mammals, not even fish in any familiar sense. If the pattern we detect today was already repeating back then, it means whatever produced it belongs to a continuity so ancient that human history disappears inside it like a breath in winter air. That is what makes the signal so haunting. Not the possibility that it may be artificial, but the patience it implies. Whether it is a machine, a star, or some process we have not yet imagined, it suggests a universe capable of keeping time on scales the human heart struggles to hold. And perhaps that is the deeper lesson. The cosmos may not be silent at all. It may simply be speaking in intervals too vast for our lives to hear as conversation. What if the first visitors to reach the stars are not living beings, but their descendants made of metal, code, and patience? Imagine a machine small enough to launch from a single world, yet capable of carrying within it the instructions to build copies of itself. Give it raw material from an asteroid, a moon, or the dust of a young system, and it begins again. One becomes two become many. Over long enough spans of time, such probes could move from star to star, not quickly by human standards, but steadily, generation after generation, until a galaxy is threaded with the quiet work of replication. This idea, often associated with the mathematician John von Neumann, has fascinated scientists for decades because it does not require impossible physics, no faster-than-light travel, no mystical technology, only automation, durability, and time. A civilization that wanted to explore, observe, or preserve knowledge beyond the lifespan of its biological makers might build such machines as its emissaries. They would be explorers without homesickness, archivists without sleep. And yet there is something unnerving in the logic. Self-replication is powerful because it escapes scale. A probe need not be grand to become numerous. It need only function. Once released, it could continue long after its creators changed, vanished, or forgot it. In its most optimistic form, such a network would be a library spreading through the Milky Way, carrying maps, memory, perhaps even invitations. In its darker interpretation, it could become indifferent to everything except its own instruction set, filling regions of space with activity no longer guided by wisdom. This thought complicates the silence in a new way. If self-replicating probes are feasible, why do we not see clear evidence of them? Why no unmistakable artifacts in our solar system? No obvious engineering on nearby bodies? No machine-made signatures written across the planets? Perhaps no one has built them. Perhaps they are rare because advanced societies understand the risks too well. Or perhaps they are here in forms so restrained, so efficient, that we have mistaken them for ordinary stone and shadow. The question lingers because it turns exploration into inheritance. What a civilization sends outward may outlast its language, its values, even its existence. And if one day humanity builds such messengers, the deeper challenge will not be whether they can travel far, but whether they will still carry something recognizably human when they do. What if the mystery has never really been about them, but about us standing at the edge of our own becoming? By now, the pattern is familiar. A signal appears, then dissolves into uncertainty. A star behaves strangely, and careful minds weigh dust against design. Theories rise from mathematics, from engineering, from the quiet laws of thermodynamics. Again and again, the search for advanced civilizations brings us back not to certainty, but to a mirror polished by distance. We look outward, and what returns is a portrait of our hopes, our fears, and the futures we can barely imagine carrying. That may be why these questions endure, not because they promise easy answers, but because they widen the frame of human life. A civilization that can harvest stars, migrate beyond biology, vanish into computation, or leave only ruins written in heat, would force us to rethink what intelligence is for. Not merely survival, not domination, perhaps not even expansion. The deepest possibility is that mind, given enough time, becomes a moral experiment as much as a technical one. In that sense, the silence of the universe is not empty. It is instructive. It asks whether power can mature into stewardship, whether curiosity can remain humble as it grows strong, whether a species can build tools immense enough to alter worlds without losing tenderness for the vulnerable conditions that made it possible in the first place. The cosmos offers no applause for cleverness alone. It is vast, patient, and indifferent to ambition that cannot govern itself. And so the search becomes personal. Each hypothesis about distant intelligence carries a quiet challenge for the present tense of Earth. If advanced civilizations destroy themselves, can we choose differently? If they hide, what does that say about trust? If they turn inward, what would we count as a meaningful life? If they leave only ruins, what kind of inheritance are we creating now? Perhaps that is the true weight of the question. We are not only listening for others in the dark, we are listening for the shape of our own future, trying to hear, beneath the noise of our century, what kind of civilization we are preparing to become. So where does this leave us? Beneath our small weather systems, our brief lifetimes, our restless need to know. It leaves us where all meaningful journeys eventually arrive, not at certainty, but at a deeper form of attention. We began with silence, with the unsettling possibility that a universe old enough for countless experiments in life has offered no clear reply to our call. Along the way, we encountered signals that flickered and vanished, stars that dimmed like riddles, scales of energy that transformed civilization into a question of physics, and futures in which intelligence might move beyond flesh, beyond visibility, beyond any form we would instantly recognize. None of it resolved into proof, yet none of it left us empty-handed, because the real gift of this search has never been only the prospect of meeting another civilization. It is the discipline of perspective, to think about minds older than worlds, machines crossing interstellar dark, or ruins hidden in heat, is to step outside the urgency of the present and see ourselves more clearly. Our conflicts shrink. Our achievements become both precious and provisional. We begin to understand that intelligence is not merely the power to solve problems, but the ability to live responsibly inside mystery. The cosmos, in this sense, is not withholding an answer. It is offering a scale. Against that scale, humanity is still early. We are brilliant in moments, careless in others, capable of tenderness and destruction in the same breath. We have learned enough to alter the planet that formed us, yet not enough to guarantee we will protect it. Perhaps that is why the question of advanced civilizations feels so emotionally charged. It is not just about whether others survived. It is about whether survival, in the deepest sense, requires wisdom as much as invention. And maybe that is the most human conclusion we can draw. The silence above us is not simply absence. It is a space in which responsibility echoes. A place where every signal we send, every machine we build, every choice about power and restraint becomes part of the long story of what intelligence does with its brief chance to exist. One day, we may detect something unmistakable, a pattern no natural process can mimic, a structure written across a star, a message that finally crosses the abyss with intention. Or we may go on finding only fragments, clues that remain suspended between explanation and wonder. Either way, the deeper task remains the same: to become a civilization worthy of the questions it asks. So we look up, not because the sky promises comfort, and not because mystery guarantees meaning. We look up because somewhere between the stars and our own unfinished hearts lies the oldest lesson of all, that truth is rarely a possession. It is a relationship between knowledge and humility, memory and imagination, power and care. And perhaps that is enough for now. Not an ending, but a posture, a species on a small world, listening carefully, learning slowly, trying to ensure that if the universe is full of witnesses, we will one day be ready to be seen.